Okay, so I'd just like to talk a little bit about exponential equations, because this is, I think it is in the GCSE course, and it's just good to know. So let's just start off by breaking down exponential equations. So the first part is exponent, and this really is basically an indices. So just anything to the power of something. So 2 to the power of 2, 3 to the power of 2, because exponent, when you increase something exponentially, it increases by a bigger value each time. So if we take in 2, in this case, 2 to the power of 1 is 2, and 2 to the power of 2 is 4, 2 to the power of 3 is 8. And what we can see is that from 2 to 4 it increases by 2, but from 4 to 8 it increases by 4, and we take the next power, it increases by 8, so it increases by a bigger amount each time. And this is basically exponent. When it increases exponentially, it increases by more and more each time. So really, just if you think about it simply, it's an indice. Now for the second part, an equation, well, this is really anything with an equal sign, just as an overview. So just 2 plus 3 equals 5. This is an equation, it has an equal sign. And more commonly, you will actually find them with unknowns such as x, y, and this is probably what you're used to when you hear the word equation. You think of unknowns. So x plus 3 equals 5, and you're probably asked to find x. And really, exponential equations are just a mix of these two. So instead of having unknowns normally as you would as a base, with everything to the power of 1, you have them being the indice. So if we were to rewrite an exponential equation, it would be 2 to the power of x plus 3 equals 5. You can see x is now the indice. And this is really what this video is going to be about. So yeah, let's just get into it. Okay, so let's start off simply. We have 2 to the power of x equals 2. Now, I think a lot of you will quickly know, if you know indices, you just know that this is x equals 1. And, well, yes, it is. Because 2 to the power of 1 is 2. So that's just a really simple example. But say we had something a bit more complex, say put x to the power of 2. Now you don't have the same base, because really what you can do here, when you have the same base, how can we rewrite 2? For example, we can rewrite 2 as 2 to the power of 1. So we have the same base, 2 to the power of x equals 2 to the power of 1. So what we can really do is we can ignore these bases because they're just going to be working in the same format. So we equate this to this, so really that just gives us the answer straight away. So if we apply this logic of getting a common base and then equating them to get some common ground and really an equation without any indices, how can we change this 4 to be a 2? Because we always will try to change the bigger number into smaller ones, or at least most of the time. So a 4, we have to write that with a base of 2. So how many 2's make up 4? Well, 2 times 2 makes up 4. And 2 times 2 can be written as 2 squared. Because it's 2 lots of 2. So we have 2 squared. And don't forget the x, you just carry that down. So 4x is just 2 to the power of 2x. Equate that to 2. And as we've seen before, 2, simple, 2 is just 2 to the power of 1. So there we go. And now we have this. We have the same base here. And we can just basically ignore it in a way. And equate these two bits. So 2x equals 1. So x equals 0.5. And this would be our answer to this. So that's really how to do it. How to do these more simple examples. So yes, let me just, trying to rub out. So those are the more simple examples. So now for something a little harder, you not only have one exponent, but you have another one. And what you would do here, you can start off by simplifying just as you would originally, but you'd see that 6 can't be simplified to a power of 2. But in fact, even if it could be, this would still not be the way to go, the method that you just seen. Because if you could just ignore the bases, you would get this. And if you put x equals 1 back in here, see 2 plus 4 is 6, not 8. So that wouldn't work. And why is that? Well, that's because it has the plus sign here, just here. And you can't ignore that, just like with multiplication, really. So we're going to need to come up with a different method. And a method to do this is no longer to necessarily find a common base. Well, you do need a common base, but you need a common base and a common indice. So here you choose the most simplified one. So here we choose 2x, and we see that 4x can be simplified to the power of 2x. So this is really just 2x times 2x, and 2x is the common ground. And what we would do here is we would give it like another algebraic value. So here I'd just give it a capital A, so that we can simplify this exponential equation that we are not familiar with into something more familiar, which is a quadratic equation. And it is worth to note here that A will have to be greater than 0. Because we can't have negative numbers. Like this cannot be negative. So A will be greater than 0, and that's just to know that if we get any negative values for A, we can just disregard those. So now if we plug A back into this, what we would get would be A plus A times A equals 6, which would go to A plus A squared equals 6, A squared plus A, take away 6 to 0, we take away 6 from both sides, and here we just have our classic quadratic equation. So we simplify this, and we get A is -3 or 2, so we have two values for A. But remember, we said that A has to be greater than 0, so we can just regard the -3, and what do we have? A equals 2. So now, what can we see? Well, we can see that we let 2x equal A, and we found out that A equals 2. So really, we can substitute this equation into this equation and get rid of this A value that we just given, and get 2x equals 2. Right? This. And what we can do from here is what we did before. Find the common base, get rid of it, find that x equals 1. And that is the answer. And whilst you might have been able to figure that out just from looking at it, because 2 plus 4 equals 6, now we know that that's the only value. But there will be some of this when there will be more than one value, and this is the example that we're going to move on to just in a bit. And this is the method that you're going to use. So here, the key points are you're going to give your common ground with your common exponent, another algebraic value. It can be A, B, C, whatever. And then replace it. Solve this bit over here, which will just be a quadratic, so if you know how to do that, you can use the quadratic formula if you're stuck. And if you don't know how to factorize, you get the values for A. You take the ones that are greater than 0, because they're less than 0, and you find A. You use those positive values and you equate them to your original exponent, and this should give you a common base, so you can just use the original method to find x. So yeah, so we're just going to be moving on to an example in a bit. Right, so this is our problem, that we're going to do at the end for this video. This is how far we're going to go up to in this video, and this is what we're going to have. So remember, what's our first step? To find a common exponent that can't be simplified anymore, ideally. So that's 2x here. This can't be simplified anymore. 4x can, so we're not going to choose that. So we want to get this 4x into a 2x. So that can be done pretty easily. 8 is 2x times 2x, take away 9, 2x plus 1 equals 0. So let's just call 2x a. Now substitute this a into these. So 8a times a, take away 9a plus 1 equals 0. Let me just move these out of the way. Okay, so this is 8a squared, take away 9a plus 1 equals 0. So we see a common quadratic equation, which we can solve to 8a plus 1a minus 1 equals 0. Wait, no, hold up. 8a take away 1 and 8 take away 1 equals 0. So what do we get for a? A is an eighth or 1. Both of these values are above 0, so we can take them both. So what we can do now, okay, is take these two and we equate them. So at one point we'll have 2x equals 1 over 8 and 2x equals 1. So this is x equals 0 and this is x equals negative 3, because 1 over 8 can be written as 2 to the power of negative 3. So yeah, so there you have your answers as x equals negative 3 or 0. So I hope you understand. Please comment down below if there are any problems.